Good day, grade 12s. I hope you guys are doing well. I hope you are well. As you are watching this video, I hope you are ready to dive into some deep maths concepts. Okay, so in this video, I'll be answering the IEB paper, Pure Maths Paper 1, which was written last year, 2022 November. Okay, I'll try to give a few tips there and there, shortcuts that are valid to use or shortcuts that are appropriate to use that are going to be very, very helpful. Okay, so yeah, let's get straight to it. I'm just going to go straight to the instructions to see if there are any that are very useful. All of them are useful, by the way, but so that we don't miss anything when we answer, it is very safe to read the instructions so that we do not lose marks carelessly. So yeah, I see. Okay, I was looking for this one to be specific. I was looking for instruction number 8. So we're going to round off our answers to one decimal place unless the question says the opposite or maybe something else. Okay, and then let's get straight to the questions. Section A, question 1. The question is so clear. Solve for x, leave answers correct to one decimal place if necessary. So in order to solve for x in question A1, you can already see that the equation is in the form of factors. So what we have to do is to just apply the zero law rule, whereby we'll say 3x minus 1 is equal to 0, or 4 minus x is equal to 0. And then the value of x here is going to be, when you transpose the 1 and then divide by 3, it's going to be 1 over 3, or x is going to be, when you transpose x to the other side, x is going to be positive 4. So these are the values of x that we got, and that question was 2 marks. Now guys, please note that it is very important for you to check your answers. So it is so important for you to check your answers by just punching them in a calculator to see if they are valid or not. Some of the answers that you might get might not be valid. So here I'm just trying to check if our answers are correct. With 1 over 3, I just go straight to my calculator and substitute x with 1 over 3. There you go, we got 0. So that means the first value of x is correct for us. And then I'm going to try for 4, the positive 4. So if we get 0, that means both our answers are valid. Moving on to question 2, under solving for x. So solving for x in question 2, as you can see here that the value of x is displayed as an exponent. That means we will have to use log. Now there's a shortcut that I use for log, whereby I say if ever you have an equation in the form of I say this will be, b will stand for base, and then e will stand for exponent, and then c for just a constant number. So if I'm given an equation in the form like this, what I do is to apply log now is it's going to be log base constant is equal to exponent. That's what I'm going to apply here. So we're going to apply log, since 3x is the exponent, that means it is going to stand alone on the other side. Then I apply log of the base of the exponent, which was 2, and then the constant, the number standing alone, which is 7. Therefore, to find x now, we're going to divide both sides by 3 so that you can have x as log of 2 and then a constant of 7 divided by 3. Therefore, the value of x is going to be, I go straight to my calculator. So there's my calculator. We say log of 2 and then 7 there, that is divided by 3. We get our x value as 0.935, but remember we are rounding this off to one decimal place, so this is going to be 0.9. That means the value of x is 0.9. There you go, you get your 2 marks just like that. Moving on to question 3. Question 3, 4 marks that we have to fight for, and this is an inequality. So to solve this inequality, basically I'm going to distribute the x which is outside, so that becomes x squared because it's x times x, minus x because it's x times -1, and then this is less than 20. As you can see here, we can have a quadratic inequality by moving the 20 to join the other terms. Now we have to factorize this this trinomial on the left hand side. Open 2 brackets, less than 0, and then we're gonna have x times x. Factors of 20, that can give you the middle term, it's 5 and 4, and then the middle sign goes to the bigger factor. There you go. Therefore, this inequality now, we're gonna get your critical values. Critical values, it's gonna be x is equal to -4 or x is equal to +5. So these are the values that we are going to use to find the actual values of x in that inequality. So what I'm going to do now, I'm going to use a number line to find the actual values of x. On the left hand side you get -4, on the right hand side you get 5. And then because of that symbol, I'm going to have open circles there at the top to show that -4 and 5 are not included in the solutions of x. And then from there, what I'm gonna do, I'm just quickly gonna use a calculator to do this trick. I'm gonna try to find the sign that belongs to numbers that are less than 4 on my number line, the sign that belongs to numbers that are between -4 and 5, as well as after 5. Now you're gonna see how this is gonna be very helpful here. So you go to the equation. I'm gonna use the one with brackets. Let's put inside here a number less than 4. You can take any number, for instance, let's take -9. Take -9, I substitute in the place of x. We have +4 bracket -9 -5, and then the answer that you get is not the main priority. The priority is with the sign that you get for the answer. So if we're solving for x here, then I just substitute the value of x by a number that is less than -4, and in our case we use -9. You can see that we got a +70. I'm going to put here now a positive sign. After using that positive sign, I will try now to find the sign that I'm going to have between -4 and +5. Let's use 0 as the number that is between -4 and 5. So you substitute in the place of x. That gives you -20. So I have a negative sign there. And then I'm going to substitute now again with the number that is greater than 5. Let's use 17. So using 17, we're going to look for the sign, and the sign that I got was positive. Now coming to find the actual values of x. If you look closely here, my trinomial or my critical values are less than 0, and in a number line the numbers that are less than 0 go to the negative side or are negative. So this is the case now where I have to join my two circles. That is the importance of the signs. To conclude, I found the values of x now to be between -4 all the way to 5. But remember, -4 is not included, so I'm going to say the actual values of x for this inequality are numbers greater than -4, but they are less than 5. Or you can write this using another notation whereby we say x will be an element of, and then you put the small bracket to show that -4 is not included, all the way to 5, close with that small bracket to show that 5 is also not included. Just like that, you will get your 4 marks. And then moving on to the next question. So question B, determine the values of p for which the roots of, and then they gave us this equation, for which the roots of are real and equal. Guys, when we talk about roots, this is just a terminology in maths, but what you must know is that when they talk about roots, we are talking about solutions, or rather answers. So the question is asking for the value or the values of p. That means we are solving for p, whereby the solutions of this equation are real and equal. So you would remember this from the topic nature of roots. Now, nature of roots, we consider what we call delta. Delta will equal to b squared minus 4ac. This is the part that you get under your quadratic formula, under the square root. So that is delta. So we take that part because a square root plays a huge role in that formula, the quadratic formula. So for your roots to be real, this number here must be a positive number. And a positive number under a square root gives you a real number. But if this number is less than 0, that means the roots will be non-real. When the roots are non-real, it means the number under the square root becomes a negative number. Okay. Let me make this practical. I'm just gonna put here the quadratic formula. So here's the quadratic formula over 2a. Here's the quadratic formula. So what I'm trying to explain here is, when we look for solutions of any kind of equation, if you've got a square root and then this number here, the entire number, which we call delta in our case, if delta here is a negative number and it's under a square root, that answer will be non-real or no solution at all. Because if just to make it practical, to put any negative number under a square root, calculator gives you math error, meaning there's no solution for that. But then if you put a positive number, you get a real number, which is an irrational number in this case. So you get a real number. Now we want our roots to be real. What I'm going to do now is, for my roots to be real, delta must be greater than 0. And then for equal roots, I'm going to make the sign also equal. Okay. Therefore, moving from here, I'm going to replace the symbol with b squared minus 4ac. This part must be greater than 0. Then I take the equation that was given. It was x bracket x minus 6 is equal to 2p. Okay. So this is the equation that was given. Let us try to expand here and put it in the standard form of a quadratic equation. This would be x squared minus 6x, transpose the 2p to become negative 2p. That's equal to 0. Now this is the equation that I'm gonna use. I'll just write it here as x squared minus 6x minus 2p gives you 0. Then to substitute now for our roots to be real and equal, the value of b is negative 6. You square that, minus 4. A is 1. And then c is the third term or the last term, which is negative 2p. Now this will help us to find the value of p. Negative 6 all squared will be 36. Minus 4 times 1 is minus 4, and then times negative 2p, which is 0. That means this is 36 plus 8, because negative 4 and negative 2 give you positive 8. Then now you can solve for the value of p, meaning I have to transpose 36 to the other side, and then the sign is going to be negative. Sorry about that. Therefore, the value of p now is just minus 36 divided by 8. Minus 36 divided by 8, yes, which you can simplify to negative 9 over 2. So that means the value of p here is equal to minus 9 over 2, which can also be written as negative 4,5. Since they said round off your answers to 2 to 1 decimal place. Easy 4 marks, guys. And then moving on to question 2, let's also try question 2. Solve for x if this equation is given. Let me just rewrite the equation. So x plus 3 bracket exponent 1 over 3 is equal to negative 2. So we have a challenge here of exponent 1 over 3. So in order to get rid of the exponent 1 over 3, we just have to multiply the exponent 1 over 3 by positive 3. So what I'm trying to do here, I'm trying to make the exponent of the bracket to be equal to 1, or rather the exponent that affect x to be equal to 1. And then what you do on the left hand side, you also do on the right hand side. This takes us to x plus 3 now, because 1 over 3 times 3 will just be 1. So we have exponent 1, and then negative 2 to the power of 3. That would be negative 2 times negative 2, which is 4 times negative 2, which is negative 8. So I have an equation now, which is a linear equation and looks easy. And then the value of x would just be minus 8. The 3 must join minus 8, so it's negative 11. That is the value of x. Now if we can just try to see if our answer is really correct, I will take the negative 11 that we got plus 3 to the power of 1 over 3 equals to, equal sign must get negative 2 there. There you go. That means the value of x that I calculated is correct. So don't forget, guys, exponent that is shady, or exponent that is very weird, try to eliminate it by doing the inverse of it, and we call that inverse operation. So I multiply that 1 over 3 at the top with 3 so that you can get 1. And then what you do on the left, you also do on the right hand side. Then that made our equation very easy. Hence we're able to get x as negative 11. The next question, solve for x if log 3 bracket x plus 5 minus log 3 x is equal to 1. Okay, so in this case, please make sure that you know the rules of log. So we're going to apply the rule of log whereby there is subtraction. Let me rewrite the question. The question is log of 3 x plus 5 minus log of 3x is equal to 1. So we have to remember the rules for log. The rules for log says if you are subtracting, let me write it here. If you are subtracting, let's say you are given log of b x minus log of the same b or the same base y is equal to whatever. Okay, this simply means this can be simplified to log of b, but inside the brackets you're going to divide x by y. That is the law basically. So please know the laws of log and how to move between them. So to make this equation easier for us, we're going to apply that law. So to apply this law, that means I'm going to have log of 3 inside the brackets. You have x plus 5 as a numerator divided by x below, that is equal to 1. And then remember what I wrote in question or the previous question, whereby I said this is the trick that I use in an equation whereby you have bx is equal to, b exponent e is equal to c, and then remember b is for the base, e is the exponent, and then c is just a constant number. You can get an exponent by using log of base times the constant. Guys, this is just something I use to remember the law or how to use log easier. Now let us try to come and apply that here. That means our equation is in that form. We're going to turn it to that. If I just label it here now using a different color, that means 1 is the value of c, using my case there. 1 is the value of c, and then the bracket, oh sorry, 1 is the value of e, the bracket is the value of c, and then 3 is the value of b. There you go. Then let's just write this now using that method. C, our constant, is x plus 5 divided by x is equal to b, which is 3, and e is 1. Now if you can just look at that. Okay, I was able to move from that guy to that guy, and then this makes it easier now for me to solve for x. We're just gonna do cross multiplication, whereby you get x plus 5 is equal to 3x, and then transpose the x to the other side. So 5 is equal to minus x from 3x, which will be 2x. Then when you divide by 2, you get the value of x as 5 over 2. But remember guys, we must leave our answers rounded off to 1 decimal place. So the value of x here is 2,5. The value of x is 2,5. So let us try to see if the answer is correct when we substitute. So substitution means we have log of 3, and then going inside the brackets, Remember, our x is 2 comma 5 plus 5, so it's 2 comma 5 plus 5 minus log of 3 again to the bracket 2 comma 5. And our answer is 1, which means the answer that we got for x is super, it's correct. Question C. So if I move down to question C, let us try to answer this question. If w is given as, or if w is equal to root of 7 minus x, then what values of x is w a non-real number? Okay, let's try to understand here. If w is square root 7 minus x, this is w. Then for what values is x? For what values will x give w or make w to be non-real? Okay, what we have to solve for here, guys, is x. Now remember what I said, a number becomes non-real under a square root if it is a negative number. So what this means is negative numbers are less than 0. So if you can make 7 minus x less than 0 and then solve for x, that will be the correct answer. So to solve for x here, we can just transpose x to the other side to become x greater than 7, or rather x greater than 7, just like that. That means any number that is greater than 7 will make w to be non-real. For instance, let's choose a number greater than 7, any number that's greater than 7. I like taking numbers that are close, not big numbers. Let's use 8. So if we use 8 and put it in the place of x, let's see if w is going to be a non-real number. So square root 7 minus 8 will be -1. And then using a calculator, what is the square root of -1? Math error, non-real. Therefore, w is a non-real when x is greater than 7. So we're able to answer that question. Then you get your 2 marks there. So the next question, solve for x if w plus 2 is equal to x plus 1. Solve for x if w plus 2 is equal to x plus 1. Oh, okay, I see, guys. I got stuck there for a moment. Solve for x if w plus 2, w we had it at the top as, this was w, so it's a follow-up question basically. That was our w, we're given w. What I'm gonna do now is just to substitute square root 7 minus x plus 2 is equal to x plus 1. Then we get an equation that we have to solve. So let's solve this equation. Moving 2 to the other side will leave you with 7 minus x square root. X 2 will become negative. 1 minus 2 is -1. And then to remove the square root, that means we would have to square both sides of the equation. So we have 7 minus x is equal to, when you expand the bracket there, it's gonna be x squared minus 2x plus 1. X squared minus 2x plus 1, yes, it's correct. And then we are going to take x and 7 to the other side so that we can have 0. So this is x squared. This becomes negative x now because the x joins negative 2. Then we plus them, that is coefficient of negative 2 and a coefficient of positive 1 give you negative 1. That's correct. And then 7 joins 1, but 7 becomes negative. So it's negative 7 plus 1, which is minus 6, or rather negative 6. Then let us try to factorize here. X and x, factors of 6 that can give you the middle term. So it's 3 and 2. The middle term sign goes to the bigger factor. And then put a plus there because 2 times negative 3 is negative 6. That means the value of x is negative 2 or positive 3. But now let us check if our answers are fine. Using a calculator, let us check if the value of x is the 1. I'm going to use the equation on step 2 on the second step. So let's try to substitute here 7 minus 2 as the value of x plus this is equal to 5. So if you can just keep in mind, I used this one, and then we got 5 on the left hand side, and then let's see if we're gonna get 5 on the right hand side as well. So it's gonna be minus 2, sorry, it's minus 2 plus 1, which is negative 1. These two are not equal. That simply means that the value of negative 2 is not a value of x in our case. So I'm just adjusting now the equal sign or the symbol to say that x is not equal to negative 2. Done with that part, let's go to the second one. So we said x is not equal to negative 2. Let's use positive 3. To use positive 3, substituting it in 7 minus so when we used 3, we got 4, and then on the other side, on the left hand side, on the right hand side, we're gonna put 3 in the place of x plus 1, that is also 4. So check, that means the value of x there is equal to 3. Guys, please note that if you do not put if you don't check your answers, you might leave one of them there, and then you find out later that the value for x is actually not that answer, and when they mark your paper, they are going to mark it wrong because that means you didn't check your answers. You gave a wrong solution basically. So let's try to find the correct solutions. Prove your answers if they are correct if you have to. And then that's it for part 1. That's it for part 1. Part 2, we will be looking at question 3, and we'll try to answer question 3, first principles, and as you can see, it moves on to derivatives, functions. Yes, we'll take it from there, guys. Otherwise, thank you so much. Enjoy the rest of your day.